All right, so today we're going to start layer 3 high availability. All right, so in this layer 3 high availability, it all always talks about the redundant gateways. We spoke about the core layers. We spoke about that the core layer will be further connected to the enterprise edge level or edge layer where we have the routers. So till access layer, distribution layer, and core layer, we have the switches. In core layer, high-end capacity switches, and then these high-end capacity switches will be connected to the further enterprise edge layer, means the routers. And then your network will be for different services. It will be connected to the different maybe WAN service provider, internet service provider, PSTN service provider, VPN, based on the requirement, right? So this particular layer 3 high availability is something where without dropping the packet, without impacting the service, it should, in case if the layer 3 gateway is unavailable or connection to the gateway is unavailable, right, the traffic should automatically forward it to the other gateway without user intervention, without manual intervention. That's
Okay, so
what
any issue with one gateway, it will transfer to the next one.
exactly. So consider this particular network where we have the computers, right? These maybe two computers are connected to this switch, and they are connected to the different gateway. Maybe this is your another switch. For topology, you can give anything anyways. And they are further connected to the router. So these are the all layer 2 switches like this, and they are connected to the machine. Now at this point, when you have this kind of network, right? So let's say the network we are running here 192, the private network we are running here is 192.168 dot anything, maybe 168 and .1.0 network here we are running. Since this is one broadcast domain, in that case, consider that the IP of this is .1 and the IP of this is .2, because they will be in the same network, isn't it? And then machines are getting the IP address through the DHCP. Maybe this is your primary DHCP server, this is secondary DHCP server. So at this point, when I configure, so in the host we have to configure the gateway, right? So if at the end, if I configure your gateway is, let's say, .1 and your gateway is also .1, in that case what they will do, corresponding to the .1, they will learn the MAC address by sending the ARP message, right? And any request to outside, any request to outside, that will go to the, let's say they are connected outside, so any request to outside, they will go to the gateway, isn't it? So if you are browsing anything, the traffic will go and to this gateway, and from this gateway the traffic will go out, right? The same if you are browsing anything from here, so traffic will go and this gateway out. So your default gateway as of now is one that is dot one,
Okay.
right? Now consider that this particular router is down,
Mm.
or this link is down, or
Mm.
WAN connection is down, right?
Mm. Mm.
These hosts will never get to know that my gateway is down.
Mm.
They have already MAC entry in their table, right?
Mm.
So they will further still send that all information to their gateway.
Mm.
Till the time we as a network engineer, we get to know about the issue that your gateway is down and traffic is down, right? Maybe
Mm.
you will quickly change this particular all traffic. Maybe through the DHCP you will configure dot two here as in gateway, dot two here as in gateway, and then all traffic will start going this way.
Mm.
But in order to do that all, we need the human intervention. We need
Mm.
manual changes.
Mm.
By but by noticing the network change,
Mm.
by changing the different gateway, right? There will be a huge loss. There will be a huge impact in the business. If your network is down for 10 minutes and the company like where the BPOs and all, right, banks and all, 10 minutes are too much for them,
Mm.
right? So that is where we have the high availability protocol. That is where we have the HSRP and the VRRP.
Mm.
In this scenario, don't you think there should be some mechanism where if these guys are unable to reach the DSCP, or these guys are unable to reach gateway, these guys should automatically get to know that, you know what, my gateway is down, let me use the another gateway, right? That is what these high, layer 3 high availability protocol does.
Mm.
So in layer 3 high availability protocols, we have three protocols. There are three protocols,
Mm.
right? Hot standby router protocol, which is normally called as an HSRP,
Mm.
virtual router redundancy protocol VRP, and the gateway load balancing protocol GLBP.
Mm.
Right. So we'll talk about HSRP in this particular CCNA. Throughout CCNA, we'll do the lab as well
Mhm.
online.
Um, can you touch like a really shallow level of VRRP?
I'm sorry.
Like once we finish HSRP,
Mm-hmm.
uh, can you briefly cover like little bit of VRRP so I'll just have an idea while making the VIF and other stuff on the VRR?
VRRP, yes, I'll theoretically I'll cover
Yeah,
whatever it
like
is.
you don't have to go very much in detail, but just to give an idea like what it is and everything.
Sure. I'll do that. Right. So HSRP overview. Now, what is this? What is HSRP? Basically,
Hot
each
spell.
of the routers that provides redundancy for a
Hmm.
given gateway address is assigned
Hmm.
to a common HSRP group.
Hmm.
Means your all gateway will be considered in a common HSRP group. One
Hmm.
router is elected as a primary router,
Hmm.
and other router will be elected as a secondary router.
Hmm.
So here we have two concepts, primary and the secondary, right? All the other remains in the listening HSRP state. So maybe you have 3-4 gateways and you have configured on HSRP on all 3-4 gateways. So out of them, one will be active, one will be, yes, primary, one will be secondary, and the other will be in HSRP listening state.
Hmm.
The routers exchange HSRP hello messages at regular interval so
Hmm.
that they can remain aware of each other's existence and that of the active router.
Hmm.
So all 3 or 4 HSRP routers will keep on sending HSRP hello, right? Which is sent in every 3 seconds, as you see here. Hellos are sent in every 3 seconds. Whole timer is 10 seconds.
Hmm.
3 times of hello. So that they can they can get to know the the existence of the other active router. HSRP is basically a Cisco proprietary protocol. Means you can implement HSRP on only Cisco devices,
Mm.
right? It sends hello messages to the multicast address.
Mm.
As I told you, HSRP is sent hello in every 3 seconds, but it will be sent to the multicast address 224.0.0.2 and using the UDP port number 1985.
Mhm.
Total, the HSRP group number can be assigned from 0 to 255. These are the HSRP group that we can assign.
Mm.
Next, preemption is disabled by default. What is preemption? Preemption is something that if you change anything like priority or anything, it will not trigger automatically. So we'll talk about this.
Okay.
HSRP supports two types of authentication, plain text and MD5 authentication,
Mhm.
right? HSRP supports tracking where it can track the interfaces, and if any tracking interface is going down, it will reduce the priority.
Mm.
So tracking is something that it can track upstream interface in case if the, or it can track the, you know, any of the subnet, and in
Mm.
case if that subnet or interface is down,
Mm.
the HSRP will bring down its priority down
Mm.
from 100 to the anything down, so that the other router will automatically become HSRP active.
Mm.
So how router election happens here in HSRP? HSRP election is based on the priority value 0 to 255, where
Mm.
by default the priority is 100.
Mm.
Highest priority is preferred. The router with the highest priority value 255 is highest, becomes the active router for the group.
Mhm.
If all router priorities are equal, which is by default, as I told you, it is 100, or set to the default value, the router with the highest IP address on the HSRP interface becomes the active router.
So HSRP is basically only physical routers, right?
HSRP will be you will implement on the yes gateways.
Like, yeah, so physical routers only. Okay.
Correct. All right. These are the HSRP states, state sequence. Disabled
Mhm.
by default. If you're not running HSRP, it will be disabled.
Mhm.
And then init,
Mhm.
in init, it will listen the HSRP packets, hello messages.
Mhm.
Listen.
Mhm.
Listen is where it knows that okay, I'm receiving the HSRP message from in multicast address, which means there is another HSRP member
Mhm.
of this group.
Mhm.
Speaks. So they both will exchange the HSRP hello message, and here the selection process happens based on the priority or the highest IP address.
Mhm.
And either router will become active or it will become standby,
Mhm.
right? All right. So what happens actually in HSRP defines a special MAC address of the from this. This is the HSRP MAC address. So we spoke about the ARP, right, where the end host will send a query to resolve the MAC address.
Mhm.
So in that case, whenever you configure HSRP, HSRP will have its own MAC address, which will be replied of any ARP request.
Mhm.
So that is 4 times 0 means this is again 48 bits. So 16 bits 0, 0C07 dot AC and XX. XX is where XX represents the HSRP group number as a 2-digit hex value. So if I have configured HSRP group 10, so in that case here it will be 0A. If I have configured 9, then 09.
Mhm.
All right. This is the configuration of the HSRP. You can create under the interface VLAN, or you can also create under the physical interface where you have to give the IP address and priorities. We'll talk about that. By default in HSRP, the load balance is not possible because one router will be active and the one router will be standby. But you can do the load balance by creating the two group. For few VLANs, configure one router as an active, and for few VLANs, configure other router as an active. So that way the load balance in HSRP is possible. Right? Two groups can be used to load balance the traffic. One group assigns an active router to one switch, and the other group assigns another active router to the other switch. Right? So that's all about the theory. Most of the things we'll discuss when we are implementing it. So let's go ahead and implement HSRP. I need one layer 2 switch. I need two computers. Now this layer 2 switch can be connected to the layer 3 switch or directly router. So let's use directly router itself. And now I have two routers. All right, and assume that they are connected to the service provider. They are connected to the single service provider, and this is the single service provider router. Anyway, this is your router. All right, so let's do the connectivity. This is connected to the switch. This is connected to the router, and these routers are connected to the right. So we'll go to the router. Anyways, this is our WAN connection, so you can also connect physical interface or anything. So let's go to the router. And all right, it is already turned on. All right, this is maybe a R2, so we'll configure here the normal basic IP schema, host name R2, and interface F0/0, and IP address 192.168.1.1 or 1.2, 255, 255, 255.0. No shutdown. We'll configure interface F0/1 as well, which is going to the WAN connection. IP address maybe 140.1.1 23.2. No shutdown. We'll go to this router. And configure host name R1, interface F0/0, IP address 192.168.1.1. No shutdown. Interface F0/1, IP address 14.1.12. Or this is 3, so 13.1. And no shutdown. What I'll do here is implement AIGRP or any protocol. So router AIGRP 100 and no auto summary and network 140.1.13.0 and network 192.168.1.0. We'll go to the other router, R3, which is the WAN router. And host name R3, interface F0/0, invalid interface type, gig 0/0, 140.1.13.3, shutdown, and interface gig 0/1, 140.1.23.3.
Mistake in the interface.
No, it is the same, right? Gig
G0.
0/0 and 0/1. Here it is coming 0/1.
Okay, you put a gigabit. Okay.
Yes. And router EIGRP 100 and network 140.1.13.0, 23.0. No auto summary. And we'll create one loop back as well, maybe 3.3.3.3. Well, we'll create one loop back 0 with the IP address 3.3.3 and with the subnet mask 255.255/ so that we can track the reachability, right? So as of now, as you see here, if let's assign the IP address to these machines, maybe IP address 192.168.1.10 subnet mask, and default gateway you will put either 1.1 or 1.2, isn't it? Either 1.1 or 1.2. Same thing in other machine, 192.168 1 dot maybe 20 and 192.168.1.1 or 1.2.
So both the routers you gave 1.1.
Now here it is 1.1, here it is 1.2. So as of now, traffic to the traffic out to outside will go via from where? From its gateway, right?
From 1.
So correct. Trace rate 3.3.3, and as you see, it is going through the 1.1. In fact, it will go from here as well. And it is also going via this way itself. Right, so all traffic it is going via this way. Now consider that in router the interface is down, maybe f0/0 1, f0/1, it is down, right?
Yep.
And do show IP IGRP neighborship it is not found. So, but if you send the traffic, right, it will still go to the dot one. And now the dot one will say destination host unreachable, isn't it?
Right.
As of now, there is no mechanism where these hosts should configure automatically that okay, this gateway is down, so let's use this. Now, network engineer will identify the issue, will rectify the issue, and then configure this as an maybe will bring this port back to the normal, or it will configure this gateway as in the primary gateway or the default gateway. By doing that, it will take some time and it will be huge loss.
Right.
Right. So that is where we can configure the HSRP. Now, in order to configure the HSRP, what we'll do is we will configure virtual IP on the same on both the routers, same virtual IP on both the router. This is not the any physical IP or anything logical IP. This is called virtual IP.
Okay.
So to configure HSRP, we have to go under interface f0/0. Under the interface, you have to configure standby and give the group number. So 0 to here it is 4095 in the router. So group number, give let's say 10, right? And say IP. What IP you want to configure as in this. That IP should be the part of same network, means 192.168.1 dot anything which is not assigned to the machine or anywhere. So 1.254, let's say I'll configure, right? So this will become now the standby HSRP IP. This is called the virtual IP. Right, and do show standby. This is the command to check actually. As you see, it is a speak. It is in a speak state and still in speak.
So when you configure this IP, the router will route all the traffic only through the virtual IP. Then it will not route through the physical IP. Is it correct?
Correct. So
And
we'll
how will it know to stop routing physical and routing through this one?
we'll come to that. We'll come to that. So as of now, you see here, this particular router has become active, and the virtual IP address is 1.254. Virtual MAC address, as you see here, it became 0A, 0C, 9FF0A. Right, this is the virtual MAC address. Hello 3 seconds, hold 10 seconds. Next hello sent in this. Preemption is disabled as we talk about. Active router is local, right? And the priority of this is 100, which is default. Standby router is unknown as of now. So which means this router is not receiving any hello packet from any of the other router or just RP routers. This router considered himself as the active. Now we'll go here as well and configure standby 10. It should be the same group number. IP
Now
192.
this is in the second router.
This is in the R2.
And you have to configure the same virtual IP, right?
Yes, the same virtual IP here as well. So do standby. As of now, it is listening. Now speak. Now As you see here, state speak to standby. And why? Because it has found the other router. Active router is 1.1,
Hmm.
right? Standby router is local, which is having the priority of 100.
So what was the command you ran after you assigned the virtual IP to this one?
Show,
Because you are
show
you are saying,
standby.
yeah, you're going so fast, my eyes cannot even register.
Show standby.
Right, right.
Right. That
Yeah.
is why I'm, apart from the typing, I'm also just repeating it.
Right.
All right. So as you see here, now this has become standby.
Hmm.
Now, theoretically, when we say that HSRP active selection happens based on the priority,
Hmm.
in this case it is default priority,
Hmm.
and then next based on the highest IP address,
Hmm.
right? So
Hmm.
theoretically, this is dot one and this is dot two.
Hmm.
So the highest IP address is dot two.
How come dot two? I didn't get that.
Here we have configured dot two in physical interface F0/0.
Oh, okay, 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 okay.
Here we have configured dot one,
Dot one, right?
right? But still, this particular R1 is saying that I am active, right? That's all happening because of the preemption is disabled in this. So since the,
So
yes,
R1 is saying he's the active because of the IP 1.2.
no, R1 is having 1.1, R2
Mm,
is having 1.2.
oh, sorry, I'm confusing with router one and R1. Okay, okay.
Okay, you can change this. Let's change it to R2. What it says, we have to power off, is it?
That's fine. That's fine. No problem.
Duplicate device names are not allowed. Okay. All right. So, right now, why it is happening? Because the preemption is disabled here,
Mm,
right? When the preemption is disabled, right? I mean, they won't be checking anything. Whichever router you configure HSRP first will become active,
mm,
right? And
mm,
the other router will become standby, and
mm.
the rest of the routers will become HSRP
So
others.
preemption will give the weight to it, right? 254 or 255 or 253. Is
Now, the
that correct?
preemption is where it will go through exactly based on the priority and highest IP address.
So how is actual priority determined by the highest IP address or by the highest priority that we will give for
Yes,
253?
highest IP address.
Not
So,
not the priority number that we assign to the router.
by default, what is priority? 100.
No, but you can also define 254, right, to a router.
Yes. So, when we assign priority to 54, right? For
Yeah.
example, this is active, this is standby. If I configure, in fact, the priority of this, that is how we configure the priority interface F0/0 and standby 10 and priority, right? Let's say priority we have 0 to 55. So I'll configure priority 120, which is more than 100.
Right.
So this router should become now active.
Right. But what if it is the other way, that the IP is dot one and priority is 120 and IP is dot two
IP, yes,
and priority is 100?
I got your question. Priority is the first preference.
Okay.
So I even though changed 120, but it is still standby. Why it is standby still? Because here there is no way of saying that, hey, router one, my priority has been changed to 120, which looks like more than you, so I should be active. There is no kind of mechanism in this,
Hmm.
right? So that is why R1 is still considering itself as an active. Now R2 will become active in this situation when R1 goes down only then,
Hmm.
right? Because when R1 goes down or the connection to R1 goes down, what will happen? HSRP R2 will not receive an HSRP hello, and after 10 seconds it will declare as in the out, and
Hmm.
this itself will make as an active,
Hmm.
right? So, but if we configure the priority here, sorry, if we configure the preemption, standby and preempt, which we let me enable it. Now immediately what will happen? This router will identify, oh, I have my priority is 120, and immediately it will tell to the other router saying, hello router, my priority has been changed to 120, hence I am taking the role.
Mm.
Right, so preemption is kind of the triggered update. Triggered will not be happening till the time preemption is disabled. Since the moment I enable the preemption here, as you see, it
Huh.
identifies its own priority and became active.
So why you are giving standby 10? What is that group number 10?
Standby is the command to configure HSRP,
Okay.
and 10 is the group number.
But we also give 10 group number to something else also, right? Before.
No, we gave only to the HSRP only.
Uh, and when you say preempt, which means the protocols, the whatever it is, it gets enabled, and that's when it will find out which IP is highest or which priority is highest.
Correct. So as you see here, these are the three commands we have entered for the HSRP,
Hmm.
right? Standby 10, IP is virtual IP,
Hmm.
priority 120, and we enable the preemption,
Right.
right? So as of now, this is active. Why? Because do show stand by, because this is having priority of 100, and as you see, active router is 1.2 with the priority. 1 second, here should be active router is 1.2, priority 100. It should be 100, 120. Okay, let me also enable the preemption here, standby 10, and then preempt.
So does the preemption act as a heartbeat, or there is another mechanism that acts as a heartbeat between the high available?
No, preemption is not a heartbeat. Before preemption itself, they were, detecting each other, but the role which they have taken, it is
Hmm.
randomly.
Right.
Whoever we have configured first, it
It
has
was
been
active. Right.
right. But now the preemption is something, as of now they will not, because we configured our R1 first, so R1 became active. Now they will not decide this active and standby role based on the highest IP address on or the priority. In order to make them decide based on this, we have to enable the preemption.
Hmm.
All right, so now this is your standby. R2 is active. So here in PCs, now gateway IP, what I will configure? I will
Uh,
configure the virtual IP 254
on the
machines.
okay.
So what will happen now when we configure 254, right?
Hmm.
These guys will send ARP request. Hello 254, can you tell me your MAC address?
Hmm.
Both the router will receive that ARP request, but
Okay.
who will reply? Whoever
Active.
is the active. So when
Right.
R2 replies saying my MAC address is this
Hmm.
switch is playing very important role here.
Hmm.
This switch will store that MAC address on this interface,
Right.
that I'm listening that MAC address on this interface,
Hmm.
right? So let's
Hmm.
say, for example, the MAC address of this is A, for example, for time being.
Hmm.
So switch will learn that MAC address that A is on F0/4 port.
Hmm.
Whenever you send traffic outside, right, maybe 3.3, what will you do? You will send R, you will say source IP is 1.10, its own IP address, destination IP 3.3, right? You look like blank here, Ketan.
Yeah. Yeah. Yeah.
Source IP will be 1.10,
Okay.
machine IP, destination IP will be 3.3,
Right.
source MAC will be its own MAC address,
Hmm.
and destination MAC address will be to the gateway MAC address, virtual IP MAC address.
Okay.
The request will go to the switch here.
Hmm.
Switch forwards the information based on the MAC address. It will check, okay, destination MAC address is this virtual MAC address A, which is I'm learning on F0/4. So let me forward that packet on F0/4, right? And the traffic will go via this way.
Right.
As of now, I see the request timeout and this. And okay, 1.2 is replying perfect, but let me see the ARP entry. What is the ARP entry? You see, this is the MAC address, physical address, which it is learning. But let me fix that first. Why they are unable to ping. Right, so R2 is unable to ping with this guy, and that is because show IP AGRP neighborship is not there. We configured EIGRP here? No, I believe no. Router EIGRP 100, network 140.1.23.0, adjacency network 192.168.1.0. Show IP EIGRP neighbor. Interface is 0/0. Router EIGRP 100 and passive interface fast Ethernet 0/0. So passive interface in EIGRP, this is one of the feature where if I don't want to send any hello packet on particular interface, I can configure that interface as in the passive interface, which is normally in the CCNP. But since I am using here,
But
so
why you have to make it passive? For what reason?
okay, there is no point of router to send hello hello packet on this interface because there is no router in this,
Oh, right, right, right. Okay.
right? So just to suppress that hello, I will configure the passive interface.
Okay, okay.
All right. Now this particular guy should be able to ping yes, and if I do trace route, the traffic should go via 1.2.
So why was it not able to ping before?
No, we haven't configured AGRP and R2.
Oh, I see. Okay.
Right. Now the same scenario. Let's say F0/1
Hmm.
is down. This interface is down.
Hmm.
Or let's say this interface is down.
Hmm.
Maybe on R2, F0/0 is down. Interface F0/0 and shut down,
Hmm.
right?
Hmm.
After
Hmm.
shutdown, what should happen here? This
Ah,
router will
should
not
be
receive
active.
HSRP hello from this router,
Right.
right? And this router will become active after 10 seconds.
So they receive the hello packet through the switch, right?
Yes,
At the
through the
bottom.
switch, correct. And as you see here, it has become active.
Right.
Now,
After
if
10.
I trace route again from the machine,
Hmm.
it will again send ARP request. And
But
now who will reply? This will reply.
1.1. Right.
And the traffic will automatically go via this way.
Right.
Right? And that's what it is happening.
Hmm.
So
So
that, yes.
no, no. Okay. So you you figured that out, right? You said, "Oh, why I am kind of quiet or dull?" Because I understand the process and the protocol and everything, configuration that you are doing. But when it comes to the steps in troubleshooting, my mind is still not able to cope up with all these ARP table and MEC table and RIB and everything. I kind of I'm not getting it like fit in my brain as a process, like the
Mhm.
troubleshooting best practice steps. So I kind of go blank because
No,
I have
whenever
not.
actually, whenever we troubleshoot, we have to keep one thing in mind, that OSI model,
Hmm.
right? And
Right.
especially in OSI model, layer 3 and layer 2 and layer 4.
Hmm.
So whenever we say, okay, what information it will be carrying with the actual ICMP ping
Right.
packet, right? So it is always like source MAC, destination MAC, source IP, destination IP, source
Right.
port and destination port. That layer 4 is still okay. But initially two layers are very important: source IP, destination IP, and source MAC and destination MAC.
Right.
Right, because
So
what happens, source IP and destination IP will anyways will be same throughout the end-to-end the destination,
right.
but MAC address will keep on changing, right? So we have to understand what MAC address it is sending that reply to, right? And what is the source MAC? It is source MAC anyways, it will take as in source particular sender MAC address, but the destination MAC address, these MAC addresses keep on varying. That's why
Right.
we have to actually use.
So one of the day when you are in good mood, when we have enough time, like after you finish one topic, and if we have enough time, maybe can we dedicate like 10-15 minutes and we can actually simulate this process. Then it will be really nice. So it will be in my brain. Then I will not forget.
Uh-huh. Yeah, we can do it. And if you remember, moreover, when I started this IP routing, that
Right.
time I told you the packet flow, what is the ARP request it will be going. Just go through that particular recording. If you don't have that video recording, I will send it to you.
Hmm.
Right. And additionally, yes, we can discuss. No problem.
Right. Right. Right.
All right, so I see here the all traffic is going via this. Now, when this interface comes up again, this router will say I am active again because I am back, and this router will consider as in fine, you are active now for me, and all traffic will again go through 1.2.
Hmm.
So do show standby and speak. We'll set. All right, so our traffic is going again via 1.2. Right, so HSRP is working fine here, and that's what how we implement HSRP, right?
Hmm.
What all we have to think about the priority, we have to think about the preemption,
Hmm.
right? And how to verify the HSRP, that is also very important.
Hmm.
And what is the virtual IP we have to configure, what is the virtual MAC address it will be replying, and overall what is the concept of HSRP, how
Hmm.
it acts actually, how the selection process happens,
Hmm.
right? All these things. All right. Next is a VRRP. So this is about the VRP, pretty much similar to the HSRP,
Hmm.
but the VRP is moreover it is open standard.
Do they
So
use? Is it necessary to use like a trunk VLAN with VRRP, or how is it like?
trunk
One of
VLAN VRRP.
huh?
No, what is the trunk VLAN VRRP?
For example, say there is a VLAN, right? VLAN 100, right? This is a trunk. The native VLAN is 101, and then okay, native VLAN is 200. Then the VLAN trunks are 100, 300, and 400. So I have seen the configuration where they do the
Yes.
virtual interface VIF,
Mm-hmm.
uh, VIF, and then they put VIF bond 0 dot 200, which means they are passing the VIF something like that through the VLAN. So I don't understand that. That's why. if I understand a little bit of VRRP, maybe when I see the configuration, it will make sense to me.
No, the same thing you can do with HSRP as well, right? When you say the VRF, so here instead of routers, you will have the switches, right? And in this switches you can configure this HSRP as well VRRP. Now the difference will be, as of now here virtual IP address we have configured under physical interface.
No, but why in the switches? Because the VRA is the router. Why the switches?
No, if that router is taking that command, as of now, as you see here, interface and VLAN, right? So I have the, let's say VLAN, for example, 10, right? And assign the IP address, anything, whatever you are running. Maybe this is for that implementation where you have, different subnets in your local area network with the different VLANs.
Right.
Right. So for example, you have, let's say 3 VLANs, VLAN 10, 20 and 30. And all 10, 20 and 30, they will have separate subnet. Right. So you can configure here, okay, VLAN interface VLAN 10 and then assign the IP address from the same subnet. Could be anything, maybe 172.168.168.10. Let's say 254, right? And the subnet mask. And whatever no HSRP you are configuring, that you have to configure under this. So let's say standby, right? And the group number, maybe 10, and with the IP, virtual IP. Similar, same thing, or you can implement VRRP as well here. And this similarly, you will configure VLAN 20, right? And under this 20, configure this standby or VRRP. And then same way 30. Now this particular router is active for 3 VLANs, VLAN 10, 20 and 30. Maybe we have VLAN 40, 50 and 60 as well. So this router, you can make it as an active for VLAN 40, 50 and 60. Right. So yes, you can do it that as well. As of now, what we have seen is on the physical interface, but you can do it on the SVI, switched virtual interface.
I see. So the trunk VLAN becomes the virtual interface. Is it correct?
Yes. Trunk VLAN will not. Yes, VLAN will become virtual because when we create this particular interfaces here, these are called SVI, switched virtual interface.
But what I'm saying, for there is one native VLAN, right? And then there are trunks. So VIF, I have never seen the VIF being created on the native, because native is the primary, and the router or the server itself is provision on that. But if there are 5 different VLANs, 100, 200, 300, 400 and 500, these are 5 trunks. Then one of the VLAN from the trunk is used for VIF.
One of the VLAN for it is used for, what is the full form of VIP?
VIF, virtual interface.
Virtual interface, yes. So this virtual interface here, it is called, in our networking Cisco language, we say switched virtual interface, SVI. And you might be saying this VIF, but the purpose will remain the same.
So
we can create the, normally.
So the VLAN that you showed, right, 10, 20 and 30, any one of them is not native. They are all trunk, right?
Yes, they could be native as well. If it is, you can configure here as a native as well, right? Native VLAN.
No, native VLAN for, see, when you put those VLANs are actually, so the routers trunk VLANs. Those are VLANs that are trunk for the routers.
Correct. I got it. I got the trunk. So over the trunk, they are forwarding the information for different VLANs.
Yeah. So usually, out of all the trunks, they only use one VLAN as a VIF.
And that one VLAN is a native VLAN.
No, it is one of the trunk.
It is one of the, okay. Okay.
trunk VLANs.
Might be they are doing some inter VLAN routing or something there,
Okay.
and under that they are configuring this HSRP or VRRP. Maybe
Mm.
that particular VLAN is the main part, which is where all rest of the machines, rest of the servers are the part of same VLAN or something.
Right.
And we
Yeah.
have other VLANs, but they are not actually playing the major role here. Maybe
Mm.
few endpoints or maybe few servers will be there on the other VLANs.
Right. Right. Okay. So because we don't use the VRTA does not use the HSRP protocol, it only uses VRRP for some.
VRP, correct, correct, because it is open standard. VRP is open standard. HSRP is Cisco.
Okay.
So in Viata routers, you cannot use HSRP. That's where the main difference is,
Okay. Okay.
right? So VRP provides one redundant gateway address from a group of routers, and the active router is called the master router. So here, instead of active and standby, here we
Yes.
have master and backup,
Correct. Correct.
right? So one
Correct.
router will be as a master and one router will be backup.
Mm.
Now the master router is one with the highest router priority in the VRP group or the highest IP address. Similar concept.
Right. So usually we use only two. Either one is 254 and the other one is 253. This is the
253.
setup. Yeah.
Correct, correct. So the group will be from 0 to 255, and the priority 1 to 254 is highest, 100 is default.
Mm.
So as you told, yes, one you can assign to 254 and one you can assign to 253.
3.
And the virtual MAC address here is this
Mm.
000fe00.01xx.
Mm.
Xx here represents as an again the group number.
Mm.
VRP advertisements are sent at 1 second. So now VRP is very fast than the HSRP,
I
because
see.
as you see HSRP 3 seconds hello, but here in VRP it is 1 second and 3 seconds, and then hold down means the traffic will be switched over in 3 seconds.
Right. And in that one, it holds on for 10 seconds before it changes, right?
Correct.
Mm.
In this, preemption is by default enabled. So the router, even if you configure first, and the other router also you configure first with the highest priority, it will automatically consider the second router as an the active master.
They also do one more configuration step in which they do something RFC, and they do a number. I forgot the number.
RFC.
For the physical interface, like in the configuration, they have an entry RFC, like preempt, right? All these steps are there.
Uh-huh.
Preempt is there, master is there, and then there is another step which is RFC compliant. So RFC and there is a number. So for the physical interface, they do RFC, but for the VIF virtual interface, they don't have RFC.
Okay.
So I don't know what it is, but I just remember the config.
Uh-huh. Uh-huh. I too not sure about RFC.
It's something for compliance.
Okay, might be because of this Viata, might be something.
Yeah.
All right, so it sends out the advertisement to the multicast address 0.18 and the protocol 112. And VRP also supports tracking,
Hmm.
where it supports authentication, plain text, and the MD5.
Now this will be same because it is an open standard.
Correct,
So whatever VRTA or somebody else, whoever uses VRRP, it will be the same. Authentication will be text and MD5 only, nothing more than that.
correct, correct, correct. So command to actually configure in this is VRRP on the interface.
Hmm.
VRRP normally is configured in the higher end actually platform, not in the normal or the medium range platform. So
I see.
in fact, we don't have the command as well to check show VRRP is not there.
Hmm.
Let me check here in the router. right? But the implementation will pretty much be will look like same as well.
Okay.
The
Okay.
same way you have to configure the virtual IP, same way you have to configure under the interface. No, you could configure under the VLAN interfaces as well.
I see. Okay. 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 This was very interesting. The whole HSRP thing. I really enjoyed it.
Because pretty much the concept wise little you are using in your network, right? So
Yeah. So, and the just to remind you, the PPT you sent me is not opening up. If you can just check and resend me, because it showed me when I try to open, it says uh, Microsoft pop up like you want to open with .ppt. If I say yes, nothing, no action is happening.
now this is
I have
normal.
I have just purchased like this. I just renewed my Microsoft Office complete package like 3 weeks ago. So everything other things are working.
Uh-huh. Maybe because I'm using Mac, right? So in Mac, anyways, it is PPT only. It is normal extension as in PPT.
Yeah.
PPTX might be there,
Hmm.
but let me check.
Yeah, no rush, no rush. Just write it down in your points, whatever if you are making some points for me, just
Mhm.
write it so we can do that later. Maybe
Sure.
you wanna take a little break, 5 minutes break. It's 9:30.
All right, let's take 5 minutes break and then start the new topic.
Okay.
Assume this particular computer, this particular port, LAN port, it is there, it is kept on the reception,
Hmm.
right? And the reception is not available. Some visitor comes and sees that this interface is okay. It's since I'm waiting, and let me get connected to the network, and then maybe for browse the internet or whatever it is. But
Hmm.
if you are a hacker, if you're not the correct guy, right, in that case might be you can misuse of this interface and connect to your laptop and maybe hack something, or maybe broadcast some traffic, some sort of spam, some sort of threads on the network.
Hmm.
So this is like leaving the security vulnerabilities,
Hmm.
right? So this in this kind of scenarios where you can protect the ports, right?
Hmm.
You know that okay, this is the machine that it gets connected all the time, or these are the two three machines, these it gets connected to the particular this port all the time, right? So at this
Hmm.
particular time, you can implement port security. Now, the port
So I
security,
actually didn't get the scenario very well.
no, so
When
anyways,
you say port, can you point what you are trying to mention as a port here?
port here, the cable, the port as an RJ45 connector, the cable.
Okay, but
Hmm.
okay, is it necessary that you mean that the physical port connection at the PC zero, or it could be fast Ethernet 001 also at the switch?
Since this is, in particular switch, it could be anything, any port, right?
No, so are you targeting when you are saying port security? Are you targeting the port at the switch, physical port at the switch, or physical port at the PC zero?
PC. Because switch is somewhere else. Switch won't be there at the reception, right?
Okay,
Switch
right.
will be in your data center somewhere where the cable is coming to the reception,
Okay.
right? So I'm talking about that scenario where someone came to the office and see that, or if it is, as I told you, if he is hacker and intend to do something wrong
Hmm.
with the company or the network, he
Hmm.
will see okay unused port, and it will connect its laptop and maybe can harm the network. In
Hmm.
that case, how will you secure that kind of these ports
Hmm.
from the switch perspective now?
Hmm.
So in order to, because we know we have to identify okay which all ports are unused, right?
Hmm.
Either we'll shut down them so that no one else should use it,
Hmm.
but there are ports which will be activated because the employees or the receptions people, they come and connect their particular computer or the laptop to that particular port.
Does this happen with the automatic services too?
Yes, that happens, yes.
Okay.
Right. So at this point, what you can do is you can implement port security, and on those ports which are maybe going to the reception or the front office or somewhere, right? How to do that and what is the process? The catalyst switches offer the port security feature to control port access based on the MAC address, right? So you have to identify your different office laptops or the machines. Maybe if you have 5 laptops and 5 machines, which get connected to particular that port often. In that case, I not identify the 4 MAC addresses or 1 MAC address, right? And then bind that MAC address with that port. So when other MAC address gets connected, right, some sort of violation happened, and the port will be automatically shut down,
I see.
right? So, for example, as you see here, in this particular, the MAC address is already connected, and I want to secure this port in the switch where this MAC address can only get connected. The MAC address, as you see here, 001 C792. 33D, right? So now what I'll do, okay, I will map this MAC address with that port, and when the other MAC address gets connected to this, or other machine with the different MAC address gets connected to this port will automatically, shut down. That's something called violation happens in the network, and whenever the violation happens, the port will be automatically shut down.
Is it the term MAC spoofing?
No, this is something called error disable.
Array disable.
Yes. So
Okay.
the switch will keep that port into the error disable mode or state, and this port immediately will be shut down. By that time, there will be alarm generated, obviously, that violation happened in the network and all, and the network engineer will identify, okay, what's happening. Maybe some other try to connect to the particular port or whatever it is. So they will rectify and then again bring that port up.
Okay.
Right. So there are actually 3 modes here in the port security. As you see, by default it is shut down, means immediately the port will be shut down and put into error disable state, right? Other than shutdown, if you don't want to shut down that port, you can also configure it in restrict. Restrict is something the port is allowed to stay up, means the port will be up, but all packets from violating MAC address will be dropped, and SNMP trap and syslog messages as an alert of the violation that there is violation happening, right? So you can still identify, okay, what's going on in the network.
So SNMP is a process or simple network something, right?
Simple network management protocol. SNMP we use for the monitoring purpose
Okay. Okay.
and capturing the network information.
Okay. 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 Oh
So
yeah, you know what is left out? What is left out? What I told you
it is
right
there in
now.
the syllabus, so we'll discuss.
No, no, no. What is left out is, remember I spoke with you about, I want to see running the packet capture, and I want to see, like, the sync that we talked about, sync packet. When
Packet capture we can
see
see
the,
now.
the three-way handshake and the sync happening, sync not happening.
I
Yeah,
got it.
I'll write it down. If it's too much bothering for you, I'll write it down.
No, it's okay. I remember. I will remember this. All right, and then next is protect. The protect is ports will still allow to stay up as in restrict mode, although the packets from violating addresses are dropped, but there won't be any messages. There won't be any syslog or SNMP track syslog messages that violation is happening. Means it is just protecting your network, but it is not letting anyone know that the violation is happening or not.
Okay.
Which is by default it is shut down. Let me see if I can see one shot here. All right. So we'll go to the switch, and I want to secure this port number F0 slash this. Right. So I'll go under interface F0 slash 1, which is going to the PC 0 in this, and say switch port security. This command is to enable the port security on the port. Right. So command rejected, fast Ethernet is in dynamic port. Now the switch port security you can only enable on the access port. So switch port mode access and switch port security. Switch port security, and these are the options here: MAC address, maximum violations. As I told you, the violation is by default shut down. The port will be shut down, right? And you can also say maximum how many MAC addresses are allowed. By default, maximum 1 MAC address is allowed. And then you can also say MAC address, means okay, this is the MAC address that you have to learn. Now if you know the MAC address, you can do copy and paste it here, but you can also do sticky is whatever MAC address is connected on this port, it will automatically learn.
Okay.
Right. So
Only
that's
the first time. Only the first time, whatever is connected.
only the first time, and it will consider that MAC address as a genuine MAC address.
Okay.
So as you see here, it is particular. I have the information on this particular. Now, if I remove this, maybe you can keep it aside.
So that this process actually hacker can simulate.
Yes, yes. Now what I'll do, I'll connect this port to this machine, right, which will have the different MAC address. Right. So now you immediately you should see the message here. Okay, the interface came up. Line protocol on this interface F0 slash 1 has came up. The interface is down and the line protocol. Let this interface come up because because of STP, right? This interface is still orange.
Right.
Yeah, the moment it becomes green, the new MAC switch will detect the new MAC address, right? And it'll violate the policy. Now it is not happening, though the color is green. Maybe in that case it didn't learn the MAC address. MAC address is sticky, but it didn't learn the MAC address. What I'll do, I'll put the genuine MAC address as an
Okay.
I'll copy paste and put it.
And then you can change it.
Yes. MAC address, and what is the MAC address? Let's say now this is the genuine MAC address. So command. Oh, this is physical host Ethernet 0 MAC address. Let's see. All right, so this is, let's say, genuine MAC address, and I'll disconnect this MAC address and connect to the other MAC address. So as of now, it's not happening here. Though we have configured the MAC address, but it is not happening. Switch port mode access and span to port for security MAC address. Maybe the software is not working or something. Okay, this port is shut down.
It got all both red.
Yes, but the interface is not coming up as you see. Even I'm putting shutdown, administratively down, but when I say no shutdown, it is still not coming. Maybe because changes state to down, administratively down. Why do show? Right, this port is down now, but I'm not seeing any error message. Show spanning T error disable. This port is down. Okay, maybe because it is connected to the different, but it is not giving the error message here, which it should give actually. Now what's happening here, as you see, it is coming up, right? But immediately when it sees the different MAC address on this interface, it is going down immediately,
Right.
right? Let me connect this port to the this computer and perform the same thing. Maybe I'll perform shutdown, which will be administratively down, and we'll say no shutdown. So here it should come up. All right. So it's coming at the end. So
Right.
it means when it detects the different MAC address on this port, it is immediately going down, shutting down, because that's the violation policy we have set it here,
Hmm.
right? And but with this machine, it is coming up because it is finding the correct MAC address, because this MAC address we have mapped it here.
Okay.
Right? So that's the reason it is coming. Right. So
Your
say
laptop,
sim simple.
your laptop battery is very low.
It's okay. It will go for 30 minutes more. So I can put switch port security and maybe the restrict. So violation and then restrict, right? So restrict is where it will restrict and generate the messages, right? But not, the port will not be shut down.
Hmm.
So even if I connect this to this particular interface, as you see the interface is up here, right? And because in this is software, so it is not giving error message. Otherwise it would have given the violation happened, and this port violation is happening from this MAC address.
I see.
This kind of error message you will see, this is log message you will see.
Hmm.
But any traffic from this you won't be able to actually send. So even if you are in like let me go to the software, the desktop command prompt, and if I ping any IP, the ping packet will not go because this interface is being protected or restricted.
Okay.
As you see, request timeout. But when I connect it here again and send the ping packet from here. Should be able to send it. Now this machine we don't have IP address anyways, but as you see here, this interface is up.
Right.
And so that is how the port security works actually. Now these security things, it is widely used. This port security and all we use in the switching in the in production as well.
I see.
Right. So you have any points to discuss? We can discuss now since we have got time. We'll start EHRP tomorrow and the other services as well.
Okay. So remember we talked about the RX and TX errors yesterday?
Yes,
Briefly.
yes.
So I don't remember the exact conversation, but are there any different kind of switch errors or only just two RX errors and TX errors?
They are different types of whatever the error packets are getting dropped on the interface, right? That will be the errors. You'll be seeing the counter, right? Number of the counters.
Right.
Right. So whenever the packet is getting dropped inbound direction while receiving, it will be calculated under RX actually.
Right,
Now,
but what does it actually mean? Does it mean anything about switch? Does it mean anything about router? What does it mean?
no, this means as you see this particular interface output, right? So whenever
Right.
you see the this is anyways the input error, as you see here, input error. Input error means these are the errors which are happening when the router is receiving.
Okay.
Right. So if you see the RX error, you should see the same number of amount or the pretty much similar in this input error as well.
On the router.
On the router. Yes.
Okay. And what is the TX error?
TX is out transmitting, means whatever you are transmitting towards the destination, wherever that particular interface is connected to.
Okay.
So
that will be output errors on the router.
On the router itself. So which means router is transmitting error. Normally we see when the interface becomes congested, interface doesn't have bandwidth, and router is unable to process any of the request. You will see that transmitting error.
Any of the errors, if the number start increasing.
Yes, the packets are getting dropped.
Okay. Okay.
Which means the
but they are getting dropped at the switch or they are getting dropped at the router?
At the router, because router will show its own information. Router will not show the switch information, right? And the same thing you can actually verify in the switch whether you are receiving the any TX error or RX error.
No, exactly. So on the GUI and in the switch config GUI, when we do the show switch errors, sometimes there are some RX and TX errors and everything else is 0, but there is at least 8 or 9 different type of thing, but I don't remember exactly what I was.
No, that's what in RX means receiving error. What all are the errors happening? These are for, as you see here, right? Sometimes you are receiving runs is called when you receive a very short packet. Then right, then the packet will be dropped. It will be kept here under the input error. Sometimes you receive very big error, big packet, so the packet will be dropped and it will be calculated here under the input error. There are CRC errors, frame errors, over and ignore errors, watchdog, multicast errors, all collision errors. All these errors are counted here as an input errors. But for example, if input error is 1000, in that case, 1000 packets which all type of errors happening, that will list here, maybe runs, giants, and the input errors, multicast, watchdog, and all. That all lost carrier, maybe because of physical interface issue. All information will be kept here.
Okay. So
So you
is
can
does this
identify.
does all of these thing mean different, right? What overrun may mean different.
Yes, yes, yes. Everything will, like in this case, like CRC. So CRC means when the packet is being, CRC is normally when the, whatever checksum you are sending from there,
Hmm.
and when router receives the different checksum, the
Hmm.
integrity, right? Whenever the integrity mismatch, the
Hmm.
packet will be dropped, and CRC counter will increase.
Okay. So do you can you recommend me any online PDF books that I can read, which is not very complicated and it still gives all these small details?
Yes, yes, the input errors and all you're talking about.
Basically, all these errors and everything for switch and routers for the networking. Is there a
Uh-huh.
book? Is there a book that, as a newcomer, as a starter, I can also understand, and at the same time, it gives a lot of information?
No, no, there won't be any book actually in this, but yes, if you check in internet, blogs will be there. What you need to know is the idea, basic idea. Rest,
Yes.
everything explanation and all will be there in the book, right?
Okay.
So as I told you, whenever the error happens, it will be counted as an input error. Now,
Okay.
because of what mechanism the error is happening, it will list,
Mm.
there are list of the things here.
Right. Correct.
Right.
Correct.
So now
Correct.
you can check in internet, okay, what is that babbles? What is that late collision? Right? What does that mean? Lost carrier,
Okay.
right? No carrier. So in that case, basically, you can go and check. So you will understand, okay, oh, this is because of this and this is because of this.
Right. Yeah, I understand couple of things. I understand the carrier, no carrier, because that's the physical connection, I suppose.
Uh-huh, uh-huh.
Cable connection, physical. But anyway, so
Correct. As you see here in pit Q, where the 0.75 and 0 means 0 is a size, maximum 75 drops 0. Right. So these all information you can see there.
okay.
Moreover, there is one more command which is very important, pretty much good. Let me check in R3. Show interface summary. No, it is not available in this. Mm, show interface summary. Show interfaces. Ethernet, fast Ethernet port, serial switchboard. This command is not there. So I'll do one thing. I will install one software in this. I'll give you the another overview of another software as well. This is one
Okay.
packet tracer where you can do all the practicals, but we have
Hmm.
one is called a GNS as well. So you can also
Yeah, GNS3, GNS3.
correct. So you can also do it on GNS. Those for
Okay.
CCNA level, this packet tracer is enough,
Hmm.
right? But yes,
Also, we still have to do all the tunnelings, right?
yes, GRE tunnel is there.
Right.
So we'll do in IPv6.
Okay. There was also another one, right? Like we discussed GRE or and then uh, IPsec or PPTP or something like that.
Hmm.
It's the curriculum.
Uh-huh.
I don't know which one.
So in this actually we have GRE.
Okay.
IPsec is not there. Only GRE is there in CCNA.
Uh-huh.
I'll also give you the syllabus or display here, and then we'll match one by one what all we have understood, what all you have doubt in any of the
Okay.
topic which we missed or something.
Mhm.
Anyways, I'll be following Cisco syllabus only, but
Mhm.
I'll still give it to you.
Mhm. And how long is the CCNP program learning?
CCNP 1 to 1 it will be 2 months.
I see.
We have three modules. One is routing, switching, and T shoot, three modules.
Mhm.
So 1 to 1, normally it is 3 months duration. and
Okay.
2.5 months normally.
Okay.
But one-to-one training, if it will be over by in 2 months.
Okay.
All right, so let's just stop it here, and tomorrow we'll start with IPv6, and then probably WAN. We'll see the buffer time.
And then, so tunneling will also be done tomorrow, or we'll do it?
Yes, tunneling also will be done tomorrow.
I see. Okay. So since we have last few days, I would request not to rush, and uh, hope that I can you can show me the stuff that before we end our sessions on Tuesday or Wednesday, we'll be able to cover everything.
Sure, sure. That I'll make sure.
Okay. Okay. Thank you.
All
Take
right,
care.
Bye bye.